Hello students, in the last video we discussed about projectile motion, the trajectory of the projectile which is parabolic, when the projectile fired at an angle theta with the horizontal, that type of projectile is called a oblique projectile. So in oblique projectile we have shown that the equation of the trajectory is parabolic, which is symmetric about a vertical axis at the maximum height position. It is symmetric, and that is a parabolic we have discussed in the last video. Again we have derived the maximum height expression, which is u square sin square theta by 2g if u is the initial velocity with which the projectile is projected with an angle theta with the horizontal. That we have discussed in the last section. Then next in this video we should calculate some of the other parameters in the oblique projectile. So as in oblique projectile we have already considered the projectile is projected like this, x and y. This is the origin of the coordinate system, right? And this is the trajectory in which it has a given initial velocity u, which makes an angle theta with the horizontal. And obviously this u has a component along x-axis, u cos theta, and vertical is u sin theta, and along this horizontal this motion is uniform, no acceleration. Vertically the velocity goes on decreasing at the maximum height, the vertical component of the velocity becomes 0. Now the other parameters, like we will find out what is the instantaneous velocity, or the velocity of the projectile which is fired at an angle theta with the horizontal at a particular instant. What is its velocity? So let us consider, to calculate that, let us consider the projectile is at the point P at a instant t, and obviously it starts from the point O, projected with the initial velocity u, and it reaches the point. So this is the initial velocity, I can show like this, which is always tangential like that, with a velocity u, and let it reach at the point P in a time interval t. So at this point P, what is its instantaneous velocity? That expression I have to calculate. So at this point P, on this curved path, if we want to find the velocity, in what direction the velocity, it is always tangential. So like this is the velocity v at an instant t. So obviously it starts from t is equal to 0, and suppose it reaches at the point P in a time t. So the time interval is t. So in this, at this time instant t, what is its velocity? That I have to calculate. So if v is the velocity, then obviously there is a component along x-axis which is parallel to x-axis, let that is your vx, and there is another component vertical to that one, let that is your Vy. The body is not at the max, I am not calculating about the maximum height. At this maximum height, already you know the expression, that is the maximum height. I am not calculating about this maximum height. I am considering at an instant t, right? So P be a point at on the trajectory of the projectile, right? And at a time t, the projectile reaches from O to P. Since the horizontal motion of the projectile is uniform, u cos theta is uniform, okay, and u sin theta changes, so there is an acceleration. That acceleration, vertical acceleration, is your ay, that is equal to minus g, already we have taken, and x component acceleration is 0 because the motion is uniform. So with that, let us consider the velocity at this point is v. So how to calculate like this? So as we know, in this part, if I make it as in your parallelogram locus, let us consider this is a parallelogram, right? and let this v is the velocity. I will have find the expression for this v, and let this v max an angle beta with the x component of that velocity, right? So now here we will calculate one by one the in this projection. Initially there is a velocity that is your vx. So at this point what would be its vx? At p what would be the vx? As you know that u cos theta, at every point this velocity u cos theta is uniform. So here it is u cos theta, here also u cos theta, here also u cos theta. So vx I can write as u cos theta. This is uniform, this does not change. The horizontal vector uniform. So u cos theta. So let us now calculate the vertical component vy of the velocity at p. For this we shall consider the vertical motion of the projectile. Let us consider this vy, calculate this vy. After knowing this vx and vy, then you know how to calculate this v. And as you know, vx and vy are mutually perpendicular. These are the two rectangular components of v. After knowing the rectangular components, already you know that how to calculate this v. So this vy part is, so for vy there is an initial velocity uy is equal to, started with u sin theta. Initial velocity is u sin theta. Then it reached at the point p, its final velocity is vy. And what is the acceleration with what acceleration along y? That is equal to minus g. Ay is equal to minus g. Okay. And the time taken, obviously the time taken t is equal to, it is taken t. So now I will calculate what is this vy. The y component, that is what is this vy. As we know, the equation of kinematics will imply vy is equal to, v is equal to uy, y component plus ay into t. So vy is equal to, what is my uy? U sin theta. Ay is minus g, plus into minus g, and obviously t. So this is my vy. As I know this vx and vy, then what is this v? There is a vector v. Think about like this. One is the vx and other one is the rectangular vy. These are rectangular components. So if this is the case, if v is the resultant of two vectors vx and vy, two vectors vx and vy, v is the resultant, then what is that v? So as you know, the resultant or the parallelogram law of vector addition, if you apply the parallelogram law of vector addition, then you can say v is equal to root over vx square plus vy square plus 2 vx vy cos 90. The angle between vx and vy is 90. Use that concept is that. Already you have derived this thing, so I am writing again. So in this part this is equal to 0. So v is equal to root over vx square plus vy square. So what is that? V is equal to square root of vx square u square cos square theta plus vy square u sin theta minus gt whole square. Clear? So after knowing that, now you solve this one. How to solve this one? So v is equal to, let me write here, v is equal to square root of u square cos square theta plus a minus b whole square u square sin square theta a square plus b square minus 2 u sin theta into gt whole square. So if you take common, so let me erase this thing. So b is equal to u square sin square theta plus cos square theta, take out u square common, so the rest is sin square theta plus cos square theta plus g square t square plus minus 2u sin theta into gt. We got this 2u sin theta into gt. Okay. So in this part I can write this is equal to, and obviously this is the square root. V is equal to u square, this is 1, plus g square t square minus 2u gt sin theta. This is the expression for instantaneous velocity, or you can write this as a v square is equal to this much. Okay, or v is equal to, you can take this as also, v is equal to, let me write, v is equal to square root of u square plus g square t square minus 2u gt sin theta. This is the magnitude of this velocity, magnitude of this velocity at the point P. Similar to any instant means for different T, what is the instantaneous velocity we can find, that is the magnitude. Then to get the direction, let it make an angle how much? Beta with x, Vx. So let, next part, so we got this V is equal to, let me erase this thing, let V makes an angle beta, let V makes an angle beta, let V makes an angle beta with Vx, the x component or Vx. Then in that part we can know that tan beta is equal to, using the parallelogram law for rectangular form, tan beta is equal to what? Vy by Vx. What is this Vy? Already we got this Vy. Vy is how much? U sin theta minus gt. Vy is what? U sin theta minus gt. So I can write tan beta is equal to u sin theta minus gt divided by Vx. Vx is equal to what? That is your u cos theta. So this means beta is equal to tan inverse u sin theta minus gt divided by u cos theta, isn't it? So this is the expression for the direction of the velocity at an instant. Okay, so in that way this gives the magnitude and direction of the velocity or the resultant velocity of a oblique projectile. Clear? Then next parameter we will go for the time of flight. Now we will find the time of flight. For that, let me erase this. Now come to the time of flight. So same, what is this time of flight means? It is the total time taken by the projectile to return back, total time taken by the projectile to return back to the same level from which it was projected or thrown. So from where it was projected, it is projected at the point O. Then it comes to the same level, right, at this point. So, okay, so same level it comes here. Then what is the total time taken to cover this thing? That is called as the time of flight. So before I calculate this thing, as already you know that this is the maximum height where it reaches, where the vertical component of the velocity becomes 0. So this is your maximum height h, already you know. And in the trajectory case, already you know that this is symmetric about this line. About this line, in the projectile motion, this is symmetry. In the oblique projection, if the projectile is projected at an angle theta with the horizontal, that already you know that. So it is symmetry. It means the time taken to move from O to, suppose, M is equal to M to N. The time taken to go from O to M is equal to M to N. So the time of flight means O to M is the time of ascent, M to N is the time of descent. So the total means time of ascent plus time of descent. Clear? In that way, so it is the time for which the projectile is in flight. Time of flight means the time for which the projectile is in flight, means in the atmosphere. Once it's thrown from the ground, suppose it's the ground, again come back to the ground, means how much time the projectile will be in the space or in the atmosphere. So, see, time of flight is equal to the twice the time by which the projectile to reach the maximum height. Why? Because it is twice the time of to reach the maximum height, because this is the time of ascent. O to m, what time taken, that is time of ascent, and the m to n is the time of descent. So this is symmetric. So time of ascent equal to time of descent. So it is 2 times the time of ascent or 2 times the time of descent. So we can say like that. So let us consider the time of flight. Let me consider this time of flight t is equal to 2 times of t. What is this t? T is the time taken to reach from O to m. O to m. T is the time taken by the projectile to reach the maximum height. T is the time taken by the projectile to reach the maximum height. Isn't it? Then that is the same time to reach from maximum height to the ground level. To reach from maximum height to the ground level. So already we know that thing. So now to know this maximum height, the time taken to reach the maximum height, means here we are considering about this path O to m. So means we are considering about the vertical motion. So obviously for this vertical motion, when we are considering this vertical motion of this one, so at this maximum height, what is your final velocity? Vy. So Vy is the final velocity at this point. What is that? 0. Final velocity is 0. And what is the acceleration due to y? Vertical acceleration, that is obviously minus g. Ay already minus g according to sign convention. And what is the initial velocity? Uy, u sin theta. So with this we will calculate the time. So as you know, the equation of kinematics, by the equation of kinematics, dy uy plus ay into t. So Vy is equal to 0, uy is equal to u sin theta minus ay is equal to minus g plus or minus t. T is the time taken to reach from O to m. So we can write this is u sin theta, that is gt is equal to u sin theta. So t is equal to u sin theta by g. So this is also called as the time of ascent. Time of ascent. And as you know, it is symmetric about this line. Time of ascent is equal to time of descent. So this is time of ascent, which is also the time of descent. So but my point is here, what is the flight, time of flight? So t, time of flight is equal to, the time of flight t is equal to, we can take this time of flight t is equal to 2 times t. So 2u sin theta by g. So this is the expression for my time of flight. Got it? Is that clear? So you can also use that in another way, is that if that in direct, if you can, this can be also derived in other way. Sometimes this is given in other books, that if I consider, without considering the ascent and descent, in this derivation I got this ascent expression and descent expression, 2u sin theta by g, of which time of ascent is equal to u sin theta by g, time of descent equal to u sin theta by g. Then combining these two, I got this time of flight. Also you can calculate for the total displacement, means suppose in this case I will say that from where it starts it comes to the same point. So in that case the total horizontal or the, we can say that the displacement during the time of flight is 0. On that basis we can use this y is equal to 0, the displacement, and with that using this s is equal to ut plus half at square, you can use that y is equal to uyt plus half ayt square. So in this case for the total time of flight to calculate, this other way is equal to, what is this uy, that is equal to u sin theta, and t the total time taken. Here I am calculating for whole, so then let that is capital T plus half, for this one is minus g, ay is equal to minus g, half g t square. U sin theta t is equal to u sin theta t minus half g t square. From here you can get u sin theta t is equal to u sin theta t is equal to half g t square. So t get cancelled. So this that t is equal to 2u sin theta by g. You can derive like this also. You can derive like this. Okay. But in this case we have to consider the total vertical displacement is 0, because from where it goes, that vertical height, how much vertical height is covered during the total flight. During the total time, the vertical height covered is 0. So that's why you consider this y is equal to 0. But horizontal it is covered some distance. Horizontal that it covers some distance. That we will find, that is called as your horizontal range. That is called as the horizontal range. Next we will calculate about the horizontal range. Okay. Next, horizontal range. Horizontal range. Generally that is taken as R. What is this horizontal range? Here horizontal range means in this projection the horizontal range is the O to N. O to N. What is that? It is the total horizontal distance from the point of projection. It is the total horizontal distance from the point of projection to the point where the projectile comes back to the plane of projection, comes back to the plane of projection. That is called as your horizontal range. So in order to calculate this horizontal range, we shall consider the horizontal motion of the projectile, because we are calculating horizontal motion. So we should consider we are calculating horizontal range, horizontal distance, that is R. So we should consider the horizontal motion. So for that, the horizontal motion is uniform motion and it takes place with a constant velocity. And what is that horizontal? Ux is equal to, as you know, we are considering the horizontal range, so that's why Ux is equal to, we consider the x component, because this is the horizontal component. So Ux is equal to u cos theta. So as you know, the total time taken to reach from O to N, that is the time of flight. So as you know, the horizontal distance or horizontal range R is equal to, what we can write? This is the velocity, that is your u cos theta, velocity, that is your u cos theta horizontally, into what is that? The time of flight, time into velocity, time of flight. Can you get like this? Can you make use this relation? U cos theta minus u cos theta into t. Why? Because as you know, this x distance here, ux equal to u cos theta. So from where it got? From where we calculate this one? As x is equal to ux into t plus half ax to t square. From there I got this one, and ax already know that it is uniform, so ax is equal to 0. X is equal to 0, so x is equal to uxt. What is that x distance? This is the range R. So x is your R, ux is your u cos theta, and time of flight. This t is the total time taken to reach from O to N, that is your capital T. From there I got this expression. Okay, so R is equal to, I can write u cos theta into the time of flight t. So R is equal to u cos theta. What is this t? Already we have got this expression for t. T is how much? T is equal to 2u sin theta by g. Remember this one. Now we have derived this 2u sin theta by g. Otherwise you go back. Right? Go back and you will see the result. So this will be 2u square sin theta into cos theta by g. What also you can write? R is equal to 2u square sin theta into cos theta by g. Or you can write this is equal to R, or you can write here this is equal to R is equal to u square. Okay, let me write here. R is equal to u square 2 sin theta into cos theta sin 2 theta divided by g. That is the expression for this horizontal range. Yes. So this is the expression for this horizontal range. And in this horizontal range, after knowing this horizontal range, what is the maximum horizontal range? When this range is maximum horizontal range. What is the maximum horizontal range? When this horizontal range is maximum. So to make it maximum, for a given velocity of projection, that is your u, for a given velocity of projection, that is already you know that u, the value of r will be maximum. The value of r will be maximum. Under what condition? When sin 2 theta is maximum. For, let me write this thing, for a given velocity of projection, that is your u. Here it is u. For a given velocity of projection u, r range is maximum because all are constant. If u is fixed constant, then g is constant. So r will be maximum. R is maximum when sin 2 theta is maximum. Sin 2 theta is maximum. Sin 2 theta is maximum. What is that sin 2 theta maximum value? The maximum value of sin theta, sin of any angle, the maximum value is plus 1. So sin 2 theta should be equal to 1. So sin 2 theta is equal to 1 means I can write this as, where this is 1, so I can write sin 90. Sin 90 is 1. So 2 theta is equal to 90. So theta is equal to 45 degree. What it means? It means what? Theta is equal to 45 degree. And again, of 45 degree, or you can say that is equal to pi by 4 radian. So that is the case. And what is the maximum range? R max is equal to, I can write here, it is already made 1, so R max is equal to u square by g. That is the expression. So what we got that information from this one? So in this part, we got that if I project a projectile at an angle of 45 degree with the horizontal, with the ground. If I throw a projectile at an angle of 45 degree to the ground or 45 degree with the vertical, here it is 45, this is also 45 with the vertical, then the projectile will reach to the maximum range. Means I will cover maximum horizontal distance. So during the throw of javelins, the coach give the instruction to the athlete that if he will give with a initial velocity u, and if the projectile, the javelin is thrown at an angle of 45 degree with the horizontal, then it will reach the maximum height. But if he is using the same initial velocity but the angle changes other than 45 degree, it will not reach to the maximum range, that is u square by g, it will not reach. So this is about the maximum range. Next, two angles of projection for the same range. Now we will find another important thing is two angles of projection. Two angles of projection for the same range. Next part we will find two angles of projection. Two angles of projection for the same range. For the same range. It means what? Two angles of projection for the same range. So as you know, R, the range R is equal to u square sin 2 theta by g. The range R is equal to u square sin 2 theta by g. If a projectile is projected at an angle theta. Now I can write this is equal to u square sin 2 theta. In place of sin 2 theta, I can write this as a sin 180 minus 2 theta. Can I write? Because sin 180 minus theta, that is sin theta by g. So it gives me what? If you equate that thing, this means we can write like this, sin 2 theta is equal to sin 180 minus 2 theta. That I can write as this is the case. From here I got sin 2 theta equal sin 180 minus 2 theta. So in that part if I write this r is equal to this or this u square sin, let me write 2 common 90 minus theta divided by g. Now you compare these two. U square by g same range for sin 2 theta and the other is sin 90 minus theta. Sin 2 of theta, sin 2 of 90 minus theta. So theta and 90 minus theta, these are called as the two complementary angle. Means what? There are two complementary angles for the same range. Means two angles of projection for the same range means the projectile can be projected with an angle theta or 90 minus theta. We will get the same range. These are called as the theta and 90 minus theta are called as the complementary angle. So there are two angles of projection for the same horizontal range, that is theta and 90 minus theta with the horizontal. The projectile will cover the same horizontal range whether it is thrown at an angle theta or 90 minus theta. The meaning is that it will cover the same range if it is thrown at an angle theta with the horizontal or 90 minus theta. So if I show this case, so this is a question like here. So the horizontal range is same whether the projectile is thrown at an angle theta with the horizontal or at an angle 90 minus theta with the horizontal. So if I show this range case in the range part, if I show the projectile motion in more clear like that in the range part to understand this range case. So let this is x and y and this is the point of projection, right? This is the point of projection and this is the trajectory. It is thrown with a velocity u which makes an angle theta. So in this case then I will throw it at an angle of 45 degree. So if it is at an angle of 45 degree, it is at an angle of 45 degree like that. So let me show like this. If it is thrown at an angle of 45 means it is in between like this. So this is the angle 45 degree at an angle 45 degree. So let me make it more clear. So you will no need to take this u. If the projectile, let me show like this, x, y, o. Okay. So if the projectile is projected at an angle of 45 degree, so this is suppose, no need to take this u part, so this is with velocity u, and if this angle is 45 degree, this is the maximum range. That is the one case. And the other one is that suppose a projectile is projected at an angle of like your 15 degree. So below this one, let me show at an angle of 15 degree. So obviously this will be the path. So if it is 50 degree, so range will be less. So this is the angle with what it is thrown. This angle is your 15 degree. Suppose it is at an angle of 15 degree. So let me show like this. And another projectile is projected at an angle of theta is 15, first case. So another one is the 90 minus 15 degree. So this is equal to 75 degree. If someone will throw a projectile at an angle of 75 degree, so this is your 75 degree. So what will be the range? The range will be like this. Same range. That my point I want to explain. Okay. So this angle is, let me show, this total angle is 75 degree. But the range is same. In both the cases, the range is same. If one is thrown at an angle of 30 degree, another is at an angle of 60 degree, both will cover the same range. Means if it is at 30 degree, if it comes at an angle 30 degree like this is the 30 degree. Then another is thrown with an angle of 60 degree, it will come to the same point. It is at an angle of 60 degree. So this is the two complementary angle for the same range. Okay students, so here we have discussed about the oblique projection, means a projectile is fired at an angle theta with the horizontal. Different parameters like the trajectory, we have proved it is a parabolic, maximum height, horizontal range, time of flight, instantaneous velocity. There are two complementary angles for the same range, and what is the maximum range. Okay, that part we have discussed in this whole section, in these two videos of oblique projectile. Then in the next video we will discuss about the projectile fired horizontally from a certain height. You go to your top of your tower or top of your house at the building top and throw a stone. So if you throw with a stone with an horizontal velocity, it will come like a parabolic path and reach to the ground. Okay, that also we will prove in the next section. Okay students, go through this whole video and you will get a clear idea about this oblique projectile. Thank you.